All right, let's talk about something big. Imagine a world where any AI can connect to any app you use just as easily as plugging in a USB-C cable. No fuss, no custom adapters, it just works. Well, that's the whole idea behind something called the Model Context Protocol, or MCP. It's a new standard that's trying to bring some serious order to the chaos of AI integrations. Let's get into it.
So, to really get why MCP is such a big deal, you first have to understand the problem it's trying to solve. You see, AI models, as smart as they are basically brains in a box. They're totally isolated. They can't see your files, they can't touch your apps, they're cut off from all your data. The only way we can get them to interact with the world is by feeding them little bits of information called tokens, and they can only pay attention to so much at once. That's their context window, kind of like their short-term memory. So getting them to do anything useful in our world is, believe it or not, incredibly difficult and super inefficient.
And this slide just lays it all out perfectly. On the left, that's where we are right now. It's what developers call the M by N problem. You've got M models and N tools, and you have to build a custom one-off connector for every single pair. It is a tangled, fragile web that costs a fortune and breaks if you look at it funny. But on the right, that's the dream. A standard protocol like MCMCP means any model can talk to any tool using one single universal language. It's clean, it's simple, and it can actually scale.
Okay, so here's how we're going to break this down. First, we'll dig a little deeper into that integration nightmare. Then I'll properly introduce MCP and its main building blocks. After that, we get to the really cool part, a pro move called code execution. Then we'll cover the serious stuff, security, and wrap up by looking at what this all means for the future.
First up, the AI integration nightmare. You know, it's not just about all those messy connectors. There's another hidden cost that's making today's AI agents painfully slow and way too expensive. People are calling it the token tax, and here's how it gets you. First, just to use a tool, the model has to read its entire instruction manual, and that gets stuffed into its limited memory. But the real killer is the redundant data. If you want to use two tools in a row, all the data from the first tool has to go back through the model's brain, only for the model to turn around and feed that exact same data to the second tool. It is a massive waste of tokens, and that means higher costs and slower answers.
Which brings us to Section 2, MCP. This is the universal protocol designed to fix both the integration mess and that nasty token tax by giving all these AI agents a shared language to speak.
Now, you might be thinking this is some crazy new technology, but it's not. And this comment from a developer on Reddit really hits the nail on the head. The value here is standardization. Think about how protocols like REST and GraphQL built the modern web. They just gave everyone a common language. That's what MCP is for AI agents. It's less about inventing something new and more about just agreeing on a really smart way to connect things. So the whole ecosystem has three main players, and the easiest way to think about them is like a restaurant. The MCP host, that's you, the diner, sitting in an app and deciding what you want. The MCP client is the waiter. It takes your order and handles all the communication with the kitchen. And the MCP server, that's the specialized chef in the back, a service that is an expert at doing one specific thing, like talking to Salesforce or Google Drive, and it prepares your request perfectly.
So let's talk about what these specialized chefs can actually do. Every single MCP server offers its skills through three core building blocks, or what they call primitives. Let's check them out. Okay, first you have resources. Think of this as read-only access, like fetching a file. The crucial part is that the application is in control here. Then you have tools. These are for taking actions that change things, like sending an email. And here, the AI model is in the driver's seat. And finally, there are prompts. These are basically reusable templates that let you guide the AI, and they are controlled by you, the user. This separation of who controls what is just a brilliant piece of design.
All right, Section 4. This is where things get really interesting. We've tackled the integration mess, but what about that token tax? Well, this is the pro move that just crushes it. It's called code execution.
Okay, check this out. On the left is the normal way of doing things. The AI calls a tool, gets some data, thinks about it, then calls another tool and passes all that data along. It's slow, but on the right is this game-changing idea from Anthropic called code mode. Instead of calling the tools itself, the AI writes a tiny little script that does the work. This means the data flows directly between the tools in a separate space, completely bypassing the AI's short-term memory.
Let's walk through that old, inefficient workflow one more time. The AI calls Google Drive to get a big meeting transcript. Boom.
That whole 50,000 token file gets stuffed into the model's brain. Then the AI calls Salesforce and has to spit that entire 50,000 token transcript right back out again. You can just feel how wasteful that is.
But with code execution, this is what the AI does instead. I mean, look how simple and elegant that is. It just writes a little script. It says, okay, I need the Google Drive tool and the Salesforce tool. It calls Google Drive, grabs the transcript, saves it to a variable, and then immediately passes that variable over to Salesforce. That huge chunk of data never even gets close to the AI's context window. It's genius.
And what's the result of this simple switch? A jaw-dropping 98.7% reduction in both the token cost and the time it takes to get an answer. That's not just a little bit better, that's a revolutionary leap in efficiency. It's what makes complex AI agents that use multiple tools not just a cool demo, but actually practical and affordable to run.
Okay, so we've just given our AI a superpower. But connecting a powerful model to all of our real-world tools and data is, a little scary. So now we have to have a serious talk about security.
The moment you give an AI the keys to your digital kingdom, your attack surface explodes. We're talking about everything from someone gaining unauthorized access to your tools, to accidental data leaks, to clever hackers tricking the AI with prompt injection. There are even risks from using unverified MCP packages someone else wrote. The list is long, and you absolutely need a solid security plan.
So how do we lock this down? It really comes down to applying security fundamentals. You need to enforce strict authentication for every single connection, no exceptions. You have to apply the principle of least privilege, which means a tool only gets the bare minimum permissions it needs to do its job. And you have to monitor and log absolutely everything so you can spot weird behavior while also sanitizing all the inputs to prevent attacks. Okay, last section. We've seen how MCP is solving these deep technical problems. So let's zoom out and think about what this means for the bigger picture, for the future of AI.
MCP is so much more than just a technical document. It's really the blueprint for a whole new software economy. By creating a universal standard, it allows a real ecosystem to grow. A world where developers can build these amazing, specialized chef servers, and then we, the users, can mix and match them together. It's what will finally let AI agents step out of the box and safely start working with us in the real world.
Which really leaves us with one last massive question to think about. If MCP becomes the universal translator for AI, if we've finally standardized how these brilliant minds talk to the world, what incredible new conversations are we about to witness? And what kind of amazing new things will we be able to build once they start? Thanks for watching.